Hello guys, and welcome back to my YouTube channel. Today we're going to be doing a few examples of resonance hybrids. So we're going to go over 3 examples, and I will walk you through step by step how I would approach drawing all the resonance hybrids. Resonance is all about the movement of electrons, so we can either move lone pairs or pi electrons in 99% of the examples that you are going to see as a second-year organic chemistry student. So step 1 is always draw in all the lone pairs. So this nitrogen would need a lone pair. And if you're wondering why this nitrogen would need a lone pair, it has to do with the octet. So we have 1, 2, 3, 4, 5 electrons that are actually owned by the nitrogen. Yes, there would be a total of 8 electrons in its octet, but the green electrons that I drew in are not technically owned by the nitrogen itself. So if we want to calculate the nitrogen's formal charge, we'd go the nitrogen formal charge would be equal to the number of valence electrons, which we can find in the periodic table. That would be 5. And then we want to minus 5 because we drew in 5. We determined the nitrogen owned 5 electrons. So overall, it would need 1 lone pair to have a formal charge of 0. And if this nitrogen had a positive charge or a negative charge, the professor would tell you. If the professor does not indicate a charge, then you would assume you need to either add enough hydrogens or lone pairs to each respective atom on a structure to ensure that they are neutral. Now, to draw our resonance hybrid, all we got to do is we got to start at either an atom with a negative charge, or an atom that is neutral with a lone pair, or an atom that has a pi bond. Okay, so here there's no atom with a negative charge. So we're going to go to our second best option, which would be a neutral atom with a lone pair. Our nitrogen, okay, so we're going to move the lone pair to in. And every 2 in is reciprocated with a 2 out, or you would break the octet rule for this carbon. So this carbon's going to break one of its pi bonds because pi bonds are weak. They are like sea otters. So these guys could flick up and onto this carbon. So what happens? The 2 electrons that initially were a part of the lone pair on the nitrogen moved towards the carbon. Therefore, those 2 electrons now are a part of a bond. Whereas the 2 pink electrons in the pi bond, those 2 electrons moved up and onto the second carbon, a part of the double bond. So those 2 electrons are now a part of a lone pair on the carbon. Therefore, overall, the nitrogen has lost electrons because we pushed electrons towards the carbon. The nitrogen will become positively charged, and this carbon will become negatively charged. And we can also confirm this by calculating the formal charges. So this nitrogen owns 1, 2, 3, 4 electrons currently. So therefore, if we wanted to calculate its formal charge, it would be 5, which we find on the periodic table. That is the number of valence electrons that nitrogen has. And then we would minus off 4, so overall it would be plus 1. Then this carbon owns 1, 2, 3, 4, 5 electrons. So the carbon's formal charge would be 4, found on the periodic table, minus 5. So that'd be negative 1. And this would be our resonance hybrid. So now for the second example. Step 1, we want to draw on all of our lone pairs. So draw on 2 lone pairs on the oxygen. Once again, this would be to achieve a neutral charge on the oxygen, because they did not tell us there was any positive or negative charges. Therefore, we assume each atom is going to be neutral. So to be neutral, this oxygen would need 2 sets of lone pairs. So once again, we'd either look for an atom with a negative charge or an atom that is neutral with lone pairs, or we'd look at a pi bond. Here, an atom that is neutral with lone pairs is our best option. So we're going to start there. Draw the back of an arrow going away from those electrons. Draw the head of your arrow in between the two atoms, the oxygen and the first carbon, a part of the double bond. Let's label these carbons 1 and 2. This is arbitrary labeling, just so I can refer to them with a notation. And every 2 in is reciprocated with a 2 out or a 2 up. And we would break the pi bond because pi bonds are weak. We want to think of them as sea otters. So these 2 electrons would flick up and onto carbon number 2. So since the electrons flew away from the oxygen will become positive, and the carbon number 2 will become negative. So this lone pair right there, I'll make it green, is now a part of a bond. And the arrowhead was pointed in between the oxygen and the carbon. Therefore, that is why the bond will be placed in between the oxygen and the carbon. And then it still has the 1 pink lone pair. Then the 2 purple electrons will go right on to carbon number 2. And carbon number 2 in the starting material would have had 1 hydrogen. Once again, this would be to ensure that carbon number 2 is neutral. So overall, its formal charge is going to be -1. And that is because it owns 5 electrons total. Therefore, if we calculated its formal charge, it would have a formal charge of -1. But usually we don't draw in the hydrogens. We just assume that they are there. So just assume that it's there. And this would be our resonance hybrid. So let's do one more example. In this example, we can see that we have a negative charge. So if we looked at our 3 options, we would choose the atom with the negative charge. So drawing that lone pair, and we push 2 in. And every 2 in is reciprocated with a 2 up. Therefore, pretend these lone pairs were originally there, the pink ones. The 2 blue electrons will now exist as a bond, a pi bond. And the 2 purple electrons now flick up and onto the oxygen. Notice, wherever the head of the arrow is drawn, that is where the electrons go. This blue head of the arrow was pointed in between 2 atoms, okay? So we formed a bond. The purple head of the arrow pointed directly at the oxygen. Therefore, we just get a lone pair. And once again, we push the electrons towards the oxygen, so the oxygen will be negatively charged in the end. And the carbon that originally had the negative charge will actually just be neutral this time because it started off with a negative charge. So originally, it would have had 1 hydrogen, so 1, 2, 3, 4, 5 electrons, including the lone pair. That hydrogen is still there. So now if we calculate its formal charge, 1, 2, 3, 4, it owns 4 electrons. Therefore, on the periodic table, it has 4 valence electrons, so we'd minus 4 electrons that it owns in the structure, so this would actually be 0. Alright guys, that is it. That is all. Hopefully this video helped. This was not a theory video. I was just going through a few examples. So let me know if you have any questions in the comment box down below. I have a few videos, if you scroll all the way down to some of my first videos on the theory behind resonance, as well as a video on my TikTok. So let me know if you have any questions. Have a good day.